Okay, so yeah, 54 students are there. Okay, we can start. Okay, so hello everyone, good morning. So, yeah. So how many of you have watched the week 7 lecture? Please raise your hand. Viraj, okay. Only 2 students. Okay, how many of you have watched lecture 7.4? It is Python to database connectivity part. Okay, no issue. So yeah, so please watch the lecture 7.4. Means all the lectures you have to watch in week 7. So in the lecture 7.4, we'll be discussing about Python to database connectivity part. So that thing we'll take in the next session. Okay. Yeah. So this week is mostly related to application development part. Okay, we have one doubt. Yes, Prashant. Prashant Kumar. We have doubt in graded assignment question. Yes.
So question number 8.
Question number 8. Okay, let me check.
So in the, can I speak, sir? What
Yes,
is my
yes.
so in this question? I can understand B is an extraneous attribute,
Okay.
but I think A and C also are extraneous attribute, as A determining D and D determining C. Then A determining C can also be extraneous.
Okay. Oh, Prashant. Yeah. So yeah, that you posted on a Discord, right?
Yes, sir.
Yeah. Okay. So A determines C is an extraneous, you mean to say, right?
Yes, sir.
Why is it so? It is a redundant functional dependency, right? Can we say that it is an extraneous attribute or not?
Sir?
It is a redundant functional dependency, A determines C. Because from
Yes.
transitivity, we can get A determines C, right?
Yes, sir.
Yeah. So can we say it is an extraneous or not?
Yes, we can, because
This is the
yes,
question, right? Yeah.
yes.
So here, okay. So first we have to check here whether it is an extraneous attribute or not, A or B, right? Because if there is a single attribute on the left hand side, we don't need to worry about it, right? Or left hand side. Then here A, B determines C. We need to check whether A is extraneous attribute in A, B determines C, or B is an extraneous attribute in A determines C. So how to check that?
As A determining B, the A determining B, so A along.
Sorry, Prashant, your voice is breaking. Is it only for me or for everyone?
No, everyone.
Prashant, can you speak again? Your voice is breaking.
So, as A determining B and A determining C, A can alone determine C.
Right. So here B is extraneous attribute, right? Okay. Then B is extraneous attribute here. Now we'll get A determine B, then A determine D, and D determines C. And if we remove B, we'll get A determines C also, right? So from A determine D determines C, we will get A determines C. Right. So A and C are extraneous or not? You want to ask this question, right? It is a redundant functional dependency, not an extraneous attribute. Extraneous attribute means like if we remove this attribute alpha, if we consider this alpha or beta, if we remove any of the component from this functional left hand side or right hand side, it is affecting the original functional dependency set or not. Okay, in the case of minimal curve, canonical curve, we can remove this functional dependency. But extraneous attribute, whether A and C is or not, we cannot say, right? Hello, Prashant.
Okay, sir. Both are means yes, sir.
Yeah, this is resultant functional
just-
dependency. We have to remove this.
We
In
can't say
during,
that A and C are extraneous attribute.
no, we cannot say
We
that.
don't.
It is a resultant functional dependency, right?
Yes.
You said in the tutorial, ma'am has
Okay, sir.
explained this.
I just
Yeah, but
yes, ma'am. Yes, sir. I just confused with that tutorial kal cover tutorial.
in the tutorial, ma'am has explained that this is a redundant functional dependency. So we have to remove from the functional dependency to get the canonical cover. Ma'am didn't say that it is an extraneous or not,
Yes, sir.
right? Okay. Still, I will check that tutorial. Okay, I will get
Yes, sir.
back to you. Yeah.
Yes, sir.
Okay.
Sir,
Then
one
next,
question.
yes.
Sir, do we have to have prior knowledge of C and Java for week 7? Like some examples were given using Java and C language.
No, you can just go through the slide. Okay. So it is there for your like information purpose. We are not going to deal with that. So we will mostly focusing on the Python to database connectivity part. That is lecture 7.4.
Okay, sir.
Yeah. I think all of you have done the Python course, right? Introduction to Python in the foundation course.
Yes, sir.
Foundation level, yeah. Is anyone direct entry to diploma here? Any student? Okay, so those who have done the Python course, it will be easier. Means only we have to connect to the database, and rest of the thing is same only. Okay, so we'll discuss that. Okay, in detail. Don't worry. Please. So before that, please watch the lecture 7.4 so that we can discuss.
Sir, are we going to discuss the practical part, like connecting with the Python?
Yeah.
Okay, sir.
So please first watch that video. Okay, in the next session we'll discuss that. Okay, so Ranjit, okay, week 7 slides are not uploaded. Okay, let me check Ranjit. I think we have sent it that slide, but okay, I will check and get back to you. Okay.
Okay, sir.
Today it will get uploaded. Yeah, if it is not done. Yeah. Week 5 GA question number 10. Priyanshu Rajput. GA, okay, grade assignment question number 10. Priyanshu, right?
Yes, sir.
Okay, right. Question number 5, grade 8.
Sir, do we have any programming questions for week 7?
Yes. We have programming questions based on Python to database connectivity part.
Okay, sir.
In the assignment also you can see that, right? Practice and graded assignment questions are there. Programming part. And in the online proctored exam, you can expect one question based on this, like Python to database connectivity part. Okay. Okay, so question number 10, graded assignment 5. Okay, just 1 minute. Yes, Priyanshu, tell me. This is the question, right?
Yes, sir.
So R is lossless decomposition of R. From among the given options, choose the functional dependency which can be removed from R that makes the decomposition lossy. Okay. Can you tell me your approach? How did you solve this question?
I didn't get the.
So what are the conditions for lossless decomposition?
So natural join of every decomposition is lossy.
Natural join.
Sir, union should be equal to R, and intersection of R1 intersection R2 must be equivalent to either R1 or R2.
Okay, then
And R1 intersection R2 should be
Should not
equal
be.
to 5.
yeah, that is empty set. Okay. So
And
here,
sir, one thing I would like to mention,
yes.
that intersection of R1 intersection R2, that is not what you said, that the term you used, who said that, Aditi, or
Equivalent.
Not
that
equivalent.
that is not equivalent. That is a key on either R1 or either R2, right?
Oh,
That
okay, sir.
Uh-huh. So R1 intersection R2 will get some attribute, and that is the, if we take the closure of that attribute, it should give us R1 or R2. Okay, so that is not equivalent. Okay, yeah, that word is not fit here. Okay. Okay, so how did you solve this question? We need to check the, okay, we have to remove the functional dependency that makes the decomposition lossy. So first we need to check the functional dependency that will make the decomposition lossless. So we can remove the decomposition. So here is R1 is ABC, R2 is ADE. So let us check for the first condition here. So it is giving me the R1 union R2, A, B, C, D, E, right? So it is equal to R, sorry, R1 union R2. Okay. So first condition is satisfied. Let us check for the another condition, that is R1 intersection R2. Yes. What is the intersection R1 and intersection R2 here? A only, right?
A. Yes, sir.
Now, if we take the closure of A, can we determine R1 or R2?
Okay.
Yes, sir.
A, B,
Yes, sir,
C,
R1.
D. So
Yes,
from
sir.
this functional
All the attributes can be determined by A. So A is a prime attribute. Yes, sir.
so we can determine R1 from A, right? So it is a lossless decomposition, but we need to remove one functional dependency that will make the decomposition lossy. So
Save
which
file.
functional dependency we have to remove this from here?
Determining B.
If we remove A determinant to C, then it will become lossy.
Yes, sir.
A determines C.
See, yes, sir. Because a determining B, a determining B from a determining C can determine B.
No. If we remove A determines C, then C and C determines E. So basically, if we remove A determines C, so E is also removed. So yes, it will make the decomposition lossy.
Okay. So if we remove A determines C, then here A determine BD. If we take the closure of A determine BD, then A BD. Then from B we can get D, and from D can we get no. Say suppose if we remove A determine B, then A C D. From C we can get E also, right? Yes, we have to remove A determine C only. So correct option is B here, right? I don't know. Let me check.
Yes, sir.
Yes, correct option is B. Yeah. Yes. Who asked this doubt? Any?
Yes,
question?
sir. Okay.
Okay. Yeah. Fine.
Thank you.
Just any other doubt in week 5 and week 6? Yes, anyone? Any doubt in how to check whether the decomposition is lossy or lossless if we have 3 or 4 decomposed relation? Hmm?
No, sir. No doubts in week 5 and 6. You can continue with week 7.
Yeah. So most of you have not watched the lecture 7.4. So yeah. That we'll take in the next session. Don't worry.
Sir, are the programming questions released or yet to be released? Sir?
Programming questions are released, right? Let me check. Lecture 7.7. Practice assignment. Okay. Oh, programming questions are not released.
For week 7,
Week 7. Yeah. Let me check. Just one.
For week 7.
Okay, okay. Programming assignment is not released yet. Okay, so today we'll release that. Okay. Sorry.
the slides are also not released for week 7.
Right. Okay, we release that too. Okay. Slides and programming assignment. Okay. Yeah. Okay, we'll release it today. Okay. Yeah.
Okay, sir.
Okay, so any doubt? Week 5, week 6. Let us take one question then. Okay, how many of you saw the SQL practice assignment? Sorry, not practice, SQL practice questions that we have released? 30 questions are there.
There are around 20 questions I have solved.
Okay, great. So you can post it on Discourse if you have any doubt. So we'll be taking one session on that. Okay.
When,
Maybe-
sir?
Maybe next week.
Okay.
Sir, in online proctored exam, do we have access to database? Means can we do practice or no?
Yeah, so before that, please solve those questions. We'll be releasing the solution on 18th of February. Yeah. So you can expect like questions, similar question in the online proctored exam also, and one question from Python to database connectivity.
Sir, the query is ki we will be accessing the database or not in the online proctored exam.
Yes, so you will be going to access or because so we'll confirm, we'll update you on that. Okay, we'll still trying out few things.
Okay, sir, fine.
Yeah. Okay, so
Sir, can you summarize week 7's first 2 lectures? The,
summarize.
yeah.
You can go through the lectures, right? That lot of contents are there. Summarize means in case what you want to discuss that in detail or summarize in the sense means
Okay,
mostly
that
theory
is
part is there, right?
yeah, that is basically the theory part. You can go through the slide, right? If you have any doubts regarding that slide part, you can ask.
So we'll be discussing Python database connectivity part here and doubts from that please. Mostly theory part is there. Okay, you can go through the content. If you have any doubt, you can ask. No issue. Then okay, let us take one question. Okay, how many of you have solved the practice problems which is given in the slides in week 5 and week 6? Mhm. Hello. Okay. Okay, let us take one example. Then, if you have any doubt, you can ask in between. Which example we should take? So in the quiz one, there was one question like pi of d, then condition was there like x less than y. So the most of you have got wrong that question because pi will remove the duplicate value, right? It is a projection operation in relational algebra. So many of you missed that part.
Hello, sir.
Yes.
Sir, can you please explain in week 5, question number graded assignment 8, how this extraneous functional attributes are removed?
Question number 8.
8.
Assignment 5, right? Yeah, we just discussed it now. I think you joined late, right?
Oh, yeah, sorry, I joined later. Yeah.
Okay, we'll discuss it again. No issue. Yeah, okay. Can you tell me your approach? How did you solve this question?
Sir, I basically cross-checked with all the attributes, removing the attributes, the functional dependency is preserved or not. Like that I have solved.
Function dependency is preserved. Nice. So we have to check whether it is there any extraneous attribute present on
Yes,
the
yes,
left hand side or right hand side. Yeah.
yes.
Sir, I think we remove a relation and we will check for the closure for that particular attribute. If we are getting the original relation, then it is an extraneous attribute.
Yeah, I mean in this functional dependency, if you remove A or B, either you will get the C or not without help of B. So then B is extraneous attribute, and if you remove A without help of A, are you getting a C or not? So yes, who asked this question? Yes, can you
Yes,
tell me
I
your
got it.
approach? Yeah?
Uh,
Here you can
I
see
know I have.
A determine B and AB determines C, right? From A we can determine B, right?
Correct, yeah.
B is an extraneous attribute here.
Oh. So without that, we can able to determine all other attributes that becomes extraneous. Okay, got it.
Okay, there was one question in the week 6 graded assignment based on MVD. Any doubt in that question? Because that is very important concept, material dependency.
So which one?
Graded assignment, week 6, MVD question. Question number 9. Question number 9? No, not question number 9. Okay, that was not in graded assignment question. Okay, so in the week 5, we have discussed about how to find out the candidate key, like then the attribute closure, then how to check whether the decomposition lossy or lossless, then dependency preserving, extraneous attribute, canonical cover, and in the week 6, we have discussed about the normalization part, then MVD. Okay, so is there any doubt in this concept? Because this week 5 and 6 is the most important topic. Yeah. So that's why we are discussing one question at least in every live session, right? Based on those concepts. Okay. Okay, so can anyone volunteer to solve this question? Yeah, my screen is visible, right?
Yes, sir.
So actually this is based on lossless decomposition part. Okay. So first we'll, okay, so just as of now, just neglect this part. So first we'll find out the candidate key. Okay, so how to find the candidate key here?
Check the right hand side.
So C, B, E, D, E. So A is there, B is there, C is there, D is there, E is there, and G is also there, right? So all the attributes are present on the right hand side of function dependency. Then in that case, what we have to do? Yes, anyone?
We have to check every pair.
Every pair, every attribute we have to check. Yeah. Right. If you have to take the closure of A, then B, then C, then D, E, and then G. Okay. So in this way, if A is from A, can we get anything? No. B closure, B, D, right? And from D determine anything? No.
No, sir.
And from C, no, C only. From D,
Nothing, sir.
no. E,
G.
E, G, yes. From G, can we determine anything? No. From G, only G. Now let us take the pair of AB, AC, AD, AE, and then AG. Now from AB we can get C, and from AC we can get B. Okay, again B. And from B I can get D, and from AD I can get E, and from E I can get G. Right. So AB is my candidate key here because from AB I can get all the attributes. Right. Then let us check for AC. From AC, okay, from B, and from AB, I get AB. From AB, I will get all the attributes. So this is also the candidate key. Anyone got this? How I conclude that from AB I can get all the attributes. So I
Yes,
can
sir. Yes, sir.
the
Understood.
closure of AB will get this R, right?
Yes, sir.
Yeah. Now AD, from ADE, yes,
E and G.
E and G.
From
Right?
Yes.
AE,
G.
yeah. Because I'm solving this question because if in the quiz you will get this type of question where you need to check all the possible combination, it will take time, right? So if you follow this approach, you can save some time, right? Now AEG, okay, no, AG. Can we find anything? No, right?
No.
So AB and AC are my candidate key. Now, if I take the combination of AB and AC with any other attribute, it will give me the same relation R, right? Now, similarly, you have to check for all the other combination, like BA we already checked, then BC, then BD, then BE, then BG. Okay.
So this is very time taking.
Yes. So
Sir, I have one trick to solve this. We
Mhm.
can take the closure of all the attributes present, like A, B, C, D, E, G. These are the all the attributes. Now we will take the closure of all these. So closure means we will get all the attributes. Now we will cross the attributes from which we are getting something, like in A, B, C, D, E, G, we can get C from A, B. So C is crossed. Okay. Now A, B, D, E, G is left. After that,
Yes.
after that, we can find E from AD. So we are crossing E also. Now the left attributes are A, B, D, G.
Right.
Yes, we can find only these are left, I think so. Yes, sir. A, B, D, G. Sir, you can write also, so that
A, B.
sir, you write all the attributes present first. A, B, C.
Yeah, A, C, D, E, G. Okay.
Yes, sir. From
cross C.
from A, B we can get C, so cross C. Now write A, B, D, E, G.
Then you can cross B also, sir.
Also,
Because-
Yes,
can
you
get G
cross
from
B also, because we can sorry, D.
No, we cannot cross B.
D.
D we can cross. Yeah.
Yes, we can get D from B. Yes. Now we can cross G. We can get it from E. Yes. So A, B, E are left. Now we can't cross these. Okay. Now
we can cross G, E also, because E can define G. So first we
no.
remove G.
We can't
No.
cross E.
Yeah.
Because to get E.
AD defined E.
Yes. So we can't cross E. Now we have got A, B, E.
We can.
Yes.
If we go from the right hand side.
Yes. We can cross E also, sir.
E can define G, so we can cross G. On the
Yes,
same
sir.
hand, B can define D, so we can cross E. So our candidate key, first candidate or super key is AB.
Yes, sir. Now we have got AB, which is a candidate key. Now we will check key the attributes which we got in candidate key are present on right hand side or not. So yes, A is present in right hand side and B is also present in right hand side. So we will see what are the attributes defining that attribute. Like for A.
1 minute,
B.
sorry. Can you please repeat it again? A, B, right hand side, you said something, right?
Sir, we got A.
Sir, sorry to interrupt. AB is a super key. Then we have to check whether AB is a candidate key. If any proper subset of AB is from any proper subset of AB, we are getting the relation. Then it is not a candidate key. Then we have to.
Yes, sir. For now, AB is a super key only. We have to check for that key. Either it is satisfying the condition of candidate key or not.
But here there is no proper subset of AB from where we can get the original relation. So AB is a candidate key.
Yes, we have to check for A and then B. They are satisfying the condition of candidate key. Then only that super key is called as candidate key. So yes, AB is a super key and then candidate key. Now we will check A and B are on the right hand side of the functional dependency or not. So yes, A is also there and B is also there. So we will replace that attribute with that to find more candidate keys. Replace means instead of A we can write BC. So B is present, so we will write C. And we will check for CB. This is satisfying as a candidate key or not.
Aditi, just for an addition, AB is a candidate key. So the prime attribute of AB is A and B. If the prime attribute is present on the right side, then there must be extra candidate key.
Yes, this point should be added. Sorry, I forgot to add. Since we have proved it as a candidate key, so yes, A and B attributes are the prime attributes.
No, you said something about the replacing of A and B. Can you do that? Instead
Yes,
of
sir.
A, can you do C?
Yeah, yes, sir.
Yes, sir. To find another candidate key, we will do this trick, this method.
Okay.
Yes, sir.
Okay.
So
Can
here
can
B
I
is a
please?
prime attribute. So we will try to replace using the second relation. So
Yes.
AC to B. So
Hmm.
we'll try replacing B with C. So
We'll try replacing B
let's
with
see.
C. Yeah.
Yeah. So if AC is doing, is AC able to find all the attributes we will be checking. So AC closure we have to check, sir.
It's not exactly C replaced. We replaced B with AC. So it becomes AAC, which is meaning as AC.
Yeah, right.
AC.
Right.
Exactly.
Yes.
Exactly.
So we cannot be direct replace here, right?
Like
So yeah, Aditya, what you said, we replace B by C. So how we can conclude that, right? That is not correct.
it
Sir,
is
We
like
can use AC determine B, then we can say that, right?
sir, it is like attribute determining prime attribute also be a candidate key.
yes, sir.
Attribute determining prime attribute.
Prime attributes
Can
can also
also be a candidate key.
candidate key.
Can also be a super key. And then we have to check it is satisfying as a candidate key or not.
Okay, so AC is also a candidate key here. Now next
BC.
BC. So how you conclude directly? Yes.
Sir, we have checked that in right hand side A is present, which is which is determined by BC.
BC
So
candidate.
we write BC. So B is already present, so we write CB, and then we check that it is satisfying candidate key or not.
Right, right. So BCA, we take the closure. Then from AB we already getting that C. From also AC we'll get AB, C. So yeah. So from that we'll get C. Okay, great. Then
Sir, that's it. Only 3 candidate key.
Yeah, AB, AC, and BC, sir.
Yes, sir.
AB is covered. AC is also covered. BC is also covered. Then we already removed this. Then D, there must be A and B also, right? So,
Yes, sir. This is the shortest trick to find candidate key, because going with all the combination is very hectic. We will miss that. So yes.
based on same concept, we have like derived that trick, right? If the attribute is not present on the right hand side, that it must be a part of candidate key, right? Similar concept was applied there also, right?
Yes, sir.
So AB, AC, BC are my candidate key. So I can say that my prime attribute will be A, B, and C, and non-prime attribute will be D, E, G. Okay. Yes, anyone, any doubt here? Yes.
Yes, sir. So we have got a way, nice way to find the candidate keys. But if it says like find the super keys, then what should we do? I mean, I know that we can use this candidate key and put other keys in combination to find the super keys. But those keys will have some combination in common, right?
Right.
Like,
so we need to subtract that.
Yeah, we need to subtract that, but that common combination, I mean, how many common combination will we have, or what is the formula to that?
Yes, sir. Sir, I would like to take the question. Okay, Abhishek, you can see there is a nice post in the discourse. I not remember the student name. He post a nice post on the discourse. You can check on that for how to find the super key.
Sir, Pushpak.
Yeah.
Yes, sir. Pushpak Roy. Yes.
Yeah. That, and I would like to also mention that this is it seems like a nice approach to find the candidate key. You can post that on the discourse also. We can check if
And
you are interested.
also, sir, one last thing, that in case of in case of transitive dependencies, you gave a trick or formula that NPA determining another non-prime attribute determining another non-prime attribute.
Yeah.
So
that is transitive dependency. Yes.
that will give us transitive dependency. So let's say AC or any two attribute is determining another attribute. So let's say AC determining E. Let's AC is determining E. So this
Sorry, 1 minute. Lot of background noise.
so AC is determining E.
Mhm.
So here E is a non-prime attribute that I know, but AC I don't know whether it is a non-prime attribute or can I say this as a non-prime attribute because there are two attributes here. So
A
can
and C as a prime attribute here, na, in this question.
no, sir, not for this one. I am talking about some other relation. So it's a candidate key, that's okay, but let's say it was not a candidate key, okay, then can we say that this is an attribute? Because when we are talking about non-prime attribute or prime attribute, we are talking about a single attribute, right?
No. Set of attributes.
Set of attributes.
Yeah.
Okay, so okay.
So this is not a transitive dependency, right?
Okay, so yes, sir. You said in the previous session only that if A is a prime attribute and C is not, so we cannot categorize this either non-prime attribute or prime attribute, but we have to check for any transitive dependence.
Yeah. So we cannot conclude that. Okay. So non-prime plus prime attribute determining non-prime attribute. Okay.
Yes, sir.
Yeah.
And sir, can you say that student's name who posted a good post regarding super key?
Pushpa Rohil, Pushpa Rohil.
You can share that link in the chat now if anyone.
Okay, yes, sir. I'm sir.
Yeah. Okay, great. So yeah, so this was about the candidate key prime attribute and non-prime attribute. Okay. Okay. Anyone would like to try the decomposition? Anyone have any confusion how to check whether the decomposition is lossy or lossless? Yes, anyone? If you didn't have any doubt, so we can skip this part. Otherwise, I can take one example here.
Yes, sir. One example can you take?
Okay. Okay, 1 minute. Okay. I'm audible, right? Hello?
Yes, sir.
Okay. Okay, so we'll check for first this decomposition D1. How to check that? We'll only take one example, okay? This one. The first condition is we need to check whether this R1 union R2 union R3 union R4 is giving me the relation R or not. So A, B, C, D, E, G. Okay. So I am getting the relation R, that is A, B, C, D, E, and G. Right. I am audible clearly or my voice is low?
Yes, sir, you are clearly audible.
Okay. So this, okay. Then next, what we have to do is anyone? Yes, anyone tell me what we have to do?
We have to find common attributes, sir.
Yeah. So which decompose relation we can take here?
So
R1, R2, R3, anything, right?
yeah, so in R1, from R1 and R2 we can get B. Now if we have to check if B is a primary key or not.
Yeah. So if we take the closure of B, are we getting R1 or R2? B, D, right? And from D, yeah. So from D, I will not get anything, right?
No.
Yeah. So I cannot take this combination. And let us check for R1 and R3.
Then we can get AB. From AB was a candidate key. So from AB we can get B.
From AB, we can get R3 or R1, right?
Yes, sir.
Okay. Now, let us say R13 as R1 union R3. That will be A, B, D, E only. Okay. Now R2 and R4 is remaining. Is there any common attribute between R2 and R4? No. Right? There is no common attribute.
E, sir.
R2 and R4.
Oh, R2 and R4. No, sir. I thought R13 and R4. Yes.
R13 and R4. Okay, you can check that also. Let us check R13 intersection R4. E, right? From E, I can get G, right? Yeah. So from E, I can get EG. So that is my R4. Now say R134 equals to R13 union R4. So that will be A, B, D, E, G. Now what is remaining? R2. Now B is the common attribute. From B, can I get C? Or from B, I can get D. And from D, I cannot get anything.
From AB, I can get C. No.
No. We are checking for R134 intersection R2. That is R2 is BC, and here common attribute is B, right? Now, if we take the closure of B, we are getting BD only.
Yes.
So we are not getting R134 or R2.
So it is a lossy join.
Lossy decomposition. Okay, so what if we take this, then we determine C. Okay, so still we cannot determine. Okay, so it is a lossy decomposition. Yeah. Quickly, can we check for second part also? Sorry. So R1 union R2 union R3 equals to A, B, C, D, E, G. So that is equals to R. Now let us take R1 intersection R2 or R3, anything. Let us take R2. Then that is AC. From AC, I can get B, right? So that is ABC. So that is R1. Now R12, say R1 union R2. That is A, B, C, D, E. Then R12 intersection R3 will be AD. Now, if I take the closure of AD, right? Yes, sir, AD. Now, if I take the closure of AD, then ADE, and from E I can get G. So I'm getting ADG here, right? R3, AD and G. So yeah. So this is a lossless decomposition. Okay, in this way you have to approach the question. Okay, any doubt regarding this? Yes, anyone? Yes, Pras. Slide number 27.15. Or Madhav is also there. Week 6 practice assignment question number 4. Okay, Madhav, we'll take that question first. Week 6 practice assignment practice assignment. Okay. Yes, Madhav, we have already discussed this question. You have any doubt in this question? You didn't understand the concept? Madhav is there?
Yes, sir. I did not understand that question. Or you have discussed in previous session, sir? Is it?
Yes, in the week 5 practice session, you have discussed this.
Okay, sir. Then I will look.
Yeah, you have to find out the highest normal form. Okay.
Yeah.
So it is as atomic value means it is already in 1NF. Now you have to check for the 2NF, right? But for 2NF, our condition is like there should be no partial dependency, right? How to check partial dependency? If suppose A determine A is a functional dependency, then how to check partial dependency? Yes, Madhav.
Candidate key determining a
Any proper subset of candidate key determining non-prime attribute.
Proper subset of
Candidate key
determining non-prime attribute, right? Now here candidate key is I think PQ.
Yes, sir.
PQ, R, S, T, U. What is remaining? V and W. So from R I can get U and V, and from V I can get W. So PQ is the candidate key, and it is not satisfying this condition, right? So it is not in 2NF if we take any other function dependency. So the highest normal form is 1NF only.
Okay.
Yeah,
okay,
you can check the week 5 session also. We have discussed that, but I think you understood, right?
Yeah, yes, sir. I understood how are you approaching. Yes.
Yes. Yes, Subhendu, did you check that slide number 27.15?
Yes, sir. Yes. Let me check it. Okay. Sorry, this question, right? This question, right? Hello, am I audible? Hello.
Hello, yes, Subhendu, you are audible.
Okay, so
Pras is there? Pras R.
Yeah, you are audible. Please go ahead.
Okay, so you have to decompose into third normal form. So relation are given C, S, J, D, P, Q, and V, and the functional dependencies are C determine C, J, D, P, Q, V, then SD determine P, then JP determines C, and the J determines C. So if you remember the how to decompose directly into third normal form, so you have to first find canonical covers. So what will be the canonical cover? So let's write the C determine.
It is of third normal form onto the relation.
Okay. Yeah, can you repeat?
Due to the properties of third normal form on the relation, I first determine the candidate key and then determine the prime attributes, and then one by one I went through the dependencies to check if they satisfy the third normal form or not. The only thing that didn't satisfy the normal form is J determining yes. So I made a relation JS, and then I removed that yes attribute from the original relation.
Yeah. Yes. Yeah, you are also right. And there is another method. You can decompose directly into third normal form. Like first we have to find a canonical cover. Then for every functional dependency, you have to make one relation. And at the last, you have to check if the candidate key is present in the relation Ri, then it's fine. Otherwise, make another relation Ri that present candidate key. So let's solve this problem. So first you have to find canonical cover. So C determine J. You can write C determine D. C determine P. C determine Q. C determine V. then SD determine P, JP determine C, and then J determine S. So you have to check which of the first you have to check which of the functional dependency are means extraneous functional dependency. So if you see the C determines C, so without the help of this functional dependency, find C closure. So what will be the C closure? So we can C determine J, C determine D, C determine P. Okay. So C closure equal to J, sorry. What will be the C closure? J, D, P, C determine Q, so Q, then V, and okay, so C determine so J, D, P, Q, V. So
Here J determine yes. By mistake it is
okay,
C.
okay, yeah. So yeah, J determines. So this is a extraneous functional dependency. So yeah, then you have to see C determine J is extraneous or not. So see without the help of C determine J, we have to find C closure. So if you find C closure without the help of this, so you will get C, D, P, Q, V, and you cannot find J. So this is not a extraneous functional dependency. Okay. Then you have to find C determine D is a extraneous functional dependency or not. So without the help of this functional dependency, you have to find C closure. So what will get? J, P, Q, V, then you also get S, also get, but you cannot find C determine D without the help of this functional dependency. So this is not a extraneous functional dependency. Then we have to find C determine P without the help of this functional dependency. What will be the C closure? So J, D, S, we can find the SD determine P. So we can get C determine P without the help of this functional dependency. So this is a extraneous functional dependency. Okay. Then we have to find this functional dependencies is extraneous functional dependency or not. So you have to find C closure without the help of this functional dependency. So what will get? J, D, P,
Yes.
S.
PQ.
Okay,
Yes.
PQ. Okay.
No, Q will not be.
Yeah, Q will not get. So this is not a extraneous functional dependency. So okay. Then we have to check this is a extraneous functional dependency or not. So without the help of C determine V, we have to find C closure. So what will get? J, D, P, then S, then I think we cannot find C determine V without the help of this functional dependency. So this is not a extraneous functional dependency. Okay. Then we have to find extraneous attributes. So what are the extraneous functional dependency? First we have to remove. So in the final, so this is the extension. So we will get C determine J, C determine D, C determine Q, then C determine V, then SD determine P, JP determine C, and then J determine S. So then we have to check extraneous attribute. So without the help of S, find D closure. So we will get P. So D closure, what we will get? Only will get D. So S is not a extraneous attribute. Then we have to check D is an extraneous attribute or not. So without the help of D, find X closure. So we'll get P. So no, we will not get P. So S is not an extraneous attribute. Okay. So then you have to check J is a extraneous attribute or not. So without the help of J, finds only preclosure. So with the help of only preclosure, we will get C. So we will only P. So J is not an extraneous attribute. Then we have to find so P is an extraneous attribute or not. So find J closure without the help of P. So this is a so find J closure. So we will only get J. So this is not an extraneous attribute. Okay. So finally we get sorry.
No, J and S, right? We are getting by using P, we are getting J, right? And from J, I'm getting S.
Okay, Asim, can you repeat?
Yeah, please write it down the right hand side. What you have erased right now?
Okay.
Yeah, the last one, P. Yeah.
Okay.
From P, we are getting J, right?
From P, we are getting J.
No, from P, we are getting.
Okay. Okay, sorry. So see, first we have to find J is an extraneous attribute or no. So find P closure without the help of J. So what will get? Only will get
J, P only.
Only P get. So
Yes.
then we have to find P is an extraneous attribute or not. So find J closure without the help of P. So what will get?
With the J only, J, I will get S, right?
Yeah, J and S.
So here I can interpret from here that S is a no, only I have to look into this, right? JP.
Yeah, so
step.
this is not an extraneous attribute.
Okay.
Okay. So we have to write final relation. So final relation is so C determine J D Q V, then JP determine C, then SD determine P, then J determine S. This is the canonical cover. I think all are get it. Canonical cover. Everyone get it, right? Hello?
Yes, we confused a little bit.
Okay.
Okay, so here first, so first we are removing the extraneous attribute, then we are removing the redundant functional dependency, and from that after we are getting this resultant functional dependency set. So this is a canonical cover, right?
Okay, actually we didn't find any
redundant functional dependency, right?
Oh, I mean that attribute, right? The extraneous attribute.
Yeah. We did not find any extraneous attributes.
Yes. So that help us to decide these things.
Yeah, if you find extraneous attribute, then you have to remove.
Okay.
You have to remove that extraneous attribute from the functional dependency. Yeah. Then you will get the canonical cover. Yeah.
Okay. So see. Okay. See, we have find all the element. We have find canonical covers. Then you have to find. Then you have to create relation Ri equal to Xi for every FD. So make for every FD. Make relations. So R1 will be C Z QV, R2 will be J PC, R3 will be
SDP,
SDP, and R4 will be
JS.
JS. So yeah. Okay, so in this relation, what is the candidate key?
The candidate keys here C, JP, and JST.
Okay, GP, JST. So see, one of the candidate key present in the relation C R1, candidate key C present in R1 relation. So one of the candidate key present in the R1 relation, any of the relation. So in the R1 relation, a candidate key is present. So we have to make any extra relation. So this is the third normal form. Everyone got it? Hello?
Yes, sir, I got it.
Okay. Asim, you got it?
Yes. No problem.
So basically, we have followed the algorithm given in the slide here in this example, right?
Yeah, for this example. Yes.
Yes.
That is multiple method, so you can try.
Yeah, there are multiple methods. Okay.
Yes.
Yeah, there is no problem. It's great.
Okay.
For me.
Okay.
And so one,
yes, sir.
one question posted on the chat box, HRC Akash. Is that an activity or practice assignment question, or you are just asking in your doubt? Akash, yes. Akash V. Okay. Yes, Pradeep, you were saying something?
Yeah, student confused about the functional that highest normal form. So you can assume the by default the functional dependency given to you that is in the first normal form, unless it is necessary, unless it is mentioned that this is the multi-valued attribute. You can assume that every attribute is in single valued attribute, right? So by default it is first normal form.
Yes, we have to check for then second enough. If it is not in second enough, then it is the highest normal form for the relation will be one enough only, right? If it is in second enough, then check for third enough. If it is not in third enough, then highest normal form will be second enough. In this way, you have to check, right?
Yeah.
Sir, can you explain Bcnf decomposition once?
Bcnf decomposition. Okay, yeah. Yes, Pradeep, you would like to take that?
Yeah, which part you did not understand? Bcnf decomposition.
Decomposition part.
Okay. Okay. Okay, let me share my screen. Okay.
Yes, Akash, in the last live session, we have taken one example. We have decomposed it into from R to Bcnf. Okay, so you can also watch that example, but still we'll discuss this today.
Okay, thank you.
Yeah, we have spent here about 50 minutes on that question to decompose from relation R to Bcnf. Yeah. Yes, Subhendra, you can.
Okay. So my screen is visible, right? Hello?
Yes, sir.
Okay, suppose relation R. Okay, so A, B, and the C. And the functional dependency are given. A determine B and B determine C. So what is the candidate key in the above relation? Anyone want to tell? Your voice is breaking. Am I audible, right? Hello.
Yes, you are audible.
Okay, so what is the candidate key in the above relation?
Who asked this question? Akash, right? Yeah.
Yes, sir. I think A is the candidate key. When reach everywhere from there.
Okay, so A is the candidate key. Okay. So how we can check that Bcnf means what are the condition that we check the relation is Bcnf or not? So what are the condition? Suppose functional dependency alpha to beta. So like alpha is must be super key. Right?
Yes, sir.
So see, A is the candidate key. So yeah. So A is the super key. So we can find A determinant B. If we take closure of A, we will get ABC. So alpha is a super key.
Yes, sir.
So then you have to find this functional dependency. So you have to see B is a super key or not. So take B closure. So what will get? BC. Right?
Yes, sir.
Okay. So this functional dependency violate Bcnf, right?
Yes, sir.
So what you have to do? So take B closure.
Subhendu,
Yeah.
I would like to correct you that here you can see that B to C is not in third NF also. Before we moving to the Bcnf, you have to first.
Yes, sir. It is. It has transitive.
Okay. So yeah. Okay. Okay. Let another example. So yeah, first we have to then we can decompose it into 3NF, then we can decompose it into Bcnf. So first we have to decompose it into third normal form. So see, B determines C violate third normal form, right? Hello.
Yes, sir.
Okay. We can directly also decompose into Bcnf. So let's.
Okay, Subhendu, let me add something. So suppose assume that these two are the functional dependency, right? A to B and so B to C. For example, right? Who is that? Akash.
Yes, sir.
Yeah. For example, consider only these two. Forget about the another functional dependency. Suppose you have these two functional dependency, A to B and B to C, and the candidate key assume that the A and C are the candidate key. I'm not calculating, just for assume. For instance, A, C are the candidate key. I'm not calculating using this functional dependency. Just assume the A, C are the candidate key, right?
Okay.
Okay. Svendu, can you write AC are the AC are the candidate key? So what is the condition of the third normal form? That A should be super key, means alpha to beta for the third normal form, right?
Right.
Okay. Svendu, can you stop sharing? Yeah, it is visible, right?
Yes, sir.
Just assume this is a kind of hypothesis. So this is the CK is your a candidate key, right? So A or C are the prime attribute, right?
Yes, sir.
A and C are the prime attribute. So here you can check, is it in third normal form or not? So what are the condition of the third normal form? Can you, alpha to beta is third normal form. So what are the condition? For the first condition, it need to be trivial, means alpha to beta, this functional dependency need to be trivial functional dependency, right?
Yes, sir.
Second one is the alpha or alpha be that super key. Yeah. And the third condition is beta is a prime attribute, right? For the third normal form. So these are the condition of the third normal form. Here you can check alpha is a prime attribute, right? Means alpha is a super key. Oh, okay, correct it. A to C. Now you can check. Is it fine? Yeah, Akash. Yeah, you are able
Yes,
to
sir.
follow me, right?
Yes,
So
sir, I am.
this particular one, A to C, this is a candidate key, right? So A to C determine B. So this is in third normal form. So next check to B to C. So B is a super key, not. So check for the C. C is a prime attribute or not. So you can check this is the prime attribute, right?
But sir, B is not a super key, no, sir.
A B is not a super key, or so, or beta is a prime attribute, right?
Okay, sir. Yes, got it.
So it satisfies this particular condition, right? Yeah.
Yes, sir.
So now check for the BCN. So what is the BCNF condition is there? First condition is if it is a trivial dependency, then we can say this is the BCNF, right? And the second one is alpha side alpha must be super key, right? So here this particular satisfy this condition, right? But this one is not satisfy the second one condition. So beta is a super key, not?
No.
No, sir. It's not.
No. So for we need to make it BCNF, we need to decompose it. So actually we are taking the wrong examples. That's why it is very difficult to decompose. But I will tell you how to decompose that particular one. So here it's come. That's the how to decompose the BCNF, right? So this is the formula for the BCNF, right? X determine A. This particular functional dependency violates the function. Suppose this is the R have the this functional dependency, right? X, Y, A. These are the attributes. This is the relation, and these are the attribute, and this is the functional dependency, right? And so many other functional dependencies here, right? So this particular functional dependency violates the BCNF condition, right? So for that decomposed, so we need to take this particular functional dependency violates the BCNF condition. So we take this as a relation R1 and make it as the, this is as the super key or the candidate key, right? Make it as the candidate key X for this particular relation. And the second one, take all the remaining attribute, right? Remaining attribute is Y. So you can check that's the BCNF. By the BCNF, you guarantee that's the this particular one is in the that lossless decomposition. Yeah, can you see this particular one? So you understand how to decompose this particular one.
But so it's not lossless, no, so it's lossy.
So
In R2, we can have to add a common attribute X. R1 is XA and R2 is XY.
yeah. I actually we take a wrong example. Actually, that's why it's making me confused. So, but this is the process. You can check on the previously we discussed on the week 6 live session. I think we already discussed
Yes, sir.
about where we discuss about the first normal form, second normal form, third normal form, and the BCNF. Already discussed about. So, yeah, here we can see this particular one is the lossless. It guarantees the lossless decomposition, right? BCNF guarantee you. Yeah, you can see that this is BCNF decomposition guarantees the lossless decomposition, but it may or may not guarantee the functional preservation of the functional dependency, right? Akash?
So BCNF
Yes,
is
sir.
third NF plus lossless decompositions.
Yeah, Asim.
Yeah. I mean, after third NF,
Yeah.
if we check the lossless decomposition is there, then it can say a BCNF, right?
No. You have to check in the third normal form is the if in every functional dependency the left hand side is on the that super key or not.
Okay.
So here you can see this is the condition for the BCNF decomposition.
Yeah, that I do understand. Up to that part is clear. No problem.
Yeah, if it is not in the BCNF, so we decompose it and so make it as the BCNF.
Okay. And relation must be there. I mean, R1 and R2, I mean, there is lossless decomposition.
Yeah, that must be. So I already explained in the previous session. I'm not sure it's the session. So here, there you can see I already explained about this. How to decompose regarding this formula also.
Yes, anyone have still doubts like the week 6 practice assignment question number 10? So that question we have discussed in detail. Week 6 practice assignment question number 10. Yeah.
Yes, sir. I will watch it.
Just any other doubt? Yes, anyone in any activity question in week 5, 6? Practice question. Any doubt in multi-level dependency? Okay, so
would you please tell me the temporal relation a little bit? I mean, I missed something. I was trying to solve some graded questions, but I have done wrongly. Sure.
graded question number week 6, right? Okay.
Yeah. Or the temporal relational some 10 questions graded as
Question
6,
number
10.
11.
No, 10.
Oh, 10. Okay. Yeah. Yes, Pradeep. Yeah. Okay, so wait just 1 minute.
Yeah, graded assignment 6.
Yes, yes, I know. Question number 10. Yes, so what do you mean by the valid time and the transaction time? Yes.
Yeah, valid time means it is when it is transaction is going on, right?
Transaction is going on. Okay.
That time we will consider, right? The temporal, relationship will build with the data.
Okay, let us take one example.
Okay.
Just 1 minute. Okay, study kind of thing. Okay, so is my screen is visible?
No, not at all.
Just now. Right? Yeah. Say suppose there is one student who joined our IITM PSC program on 23rd of March. Okay, 2021. And then okay, so he's going record. Is there any question related to that? Raji, do you have any question related to that?
You can you know about the valid time or the transaction time, right?
Yes.
What is the valid time, right? So here you can see in the slide given that one example is there. That's the valid time. Suppose a man born in, suppose, think about the 10 December 1997, right?
Yes.
But his father that registered that particular date of birth on the 15 December 1997, right?
Yes.
So, okay, let me write. So his date of birth is original. So what is the valid time is that is true in the real world, right? And the transaction time is that is valid in the database. Means when you put that entry on the database.
Yeah,
right?
transaction time is the entry time and the DOB is the actual
Actual in the real means
Yeah.
So here you can see date of birth, actual date of birth is 10 December 12 1997, right?
Yeah, yeah.
And the actual that registered on the database system, that is the 15 12 1997, right? So what you have to mention in that, so in the valid time, what is the valid time that is exist on the that is happened in the real world?
Yeah, but
means suppose you take the DOB and yeah. Yeah,
that is the historical information. I mean, is the past data.
Yeah.
But how can I check that this one is not valid and is not valid? Is there any options?
So the time when the actual event took place, so that we can consider as a valid time, right? So here date of birth 10/12/1997 is a valid time.
Yeah, that is a valid time. Yes.
And here 15/12/1997, that is a transaction time, means where when the information get updated, right?
Yes.
Yeah. Yes, Pradeep.
Oh, okay. Information get updated. Okay. Please go ahead.
Yeah, transaction time means when the information when we enter in the database, so that information will be considered as transaction time. Like in this case, 15/12/1997.
Yeah.
So
suppose
and
you
at the time of transaction, it is rolling back when I'm updating the data, right? The old data is gone. Yeah. Okay.
Suppose you add some name in the relation name and the address, right? And the address is a valid. One is the valid time, and the one is, and another is the transaction time, right?
Yes.
So hence the valid time address is suppose just right, and the address is right.
Okay, I'm staying in the sense from this. Okay, the particular date. Is it
Yeah, it's the valid time. Right, and the second one is the transaction time.
Yeah.
In this way, yeah.
When
in
I'm
this
entering
way, yeah. In this way, you can record the this particular record. So in previously, if you can see the snapshot of the data set means we use one term that is the instant, right?
Yeah.
For that instant of the database, there you can see this particular one is not there. This time stamp is not mentioned on this particular data. Whatever we have provided the data to you. So you can see just like the name of the student and the address, and there is not valid times between how I hope you get that point.
Yeah, just take simple example. Like we have completed this DBMS course on say suppose 23rd of March, but we are updating it into database on 24th of March. So the valid time will be 23rd of March and the transaction time will be 24th of March.
Yes. There is no confusion between. Yeah. There is no confusion between. Actually, what I thought, I mean, the transaction time is the rollback information. Where I thought, yeah.
It is also correct. No? Transaction time is the rollback information, right?
Yeah. I didn't think that. Okay. Clear. To me.
Thank you.
I'm changing the data to this. Yes. Updating.
In that question, option A and B are correct, right?
Yeah, option A or B are correct. Yes. Actually,
okay.
Yeah, I got it.
Yes. Any other doubt? Week 5, week 6. Okay, so yeah. So how many of you have watched the at least first 2 lecture of week 7? Just raise your hand. Okay, only 2-3 people. Okay. Okay, so please watch the week 7 lectures. Okay. Okay, we can take few questions on period. I think. Yeah, theory questions based on week 7. Yes. Anjana, Pradeep, yes.
Yes. My screen is visible, right? Hello?
Yes, Anjana, visible. Yes.
So my screen is visible, right?
Yes, visible. Yeah.
I've shared the link. Can all of you go through the peer deck and like you can use this joinpd.com and you can use the link that I shared earlier. Or I've also shared the link. You can directly go through that. So we'll wait for some time for all of you to join. After that, we'll begin.
We'll write like ABC, right?
Sorry?
Answer will be ABC, like. Okay.
You have to enter the
Yeah,
correct
text.
option.
Yes.
Only 12 students. 13.
Only 13 students have joined.
Oh, okay.
Okay, Anjana, yeah, we can continue.
Okay, sure, sir. Okay, so our first question is, which among these layers is responsible for providing the graphical user interface? So you all can see a text box, I guess. So you'll have to write down the correct answer according to you. So we'll wait for 5 minutes for you to answer.
In this, I think we can check the responses. 19 responses are there.
20 responses. Okay, sir. So
Presentation
presentation layer, presentation layer.
Yes, presentation layer.
See. Okay. So, would anybody like to volunteer and tell why the answer is presentation layer and why the one who answered application layer? Can anybody unmute and tell?
No, presentation layer means it is showing the data or information on the GUI screen.
Correct.
But application logic is the internal logic. Suppose if some condition need to specify, suppose I have one, okay, age value, right? Okay, 20 to 30 is very young age, 30 to 40 middle age, 40 to 50 is kind of logic need to apply in the logical layer. I mean, application logic layer. Or some other, I mean, data related logic maybe. It depends, I mean, what kind of application I'm going to develop. That's it.
Yeah. So, would anybody else like to tell something on this?
And data access there. Data access there. Just, I mean, when that layer will handle the data. I mean, saving data and retrieving data from there.
That's correct. Yeah. Okay, then, sir, we can head to the next question, right?
Yes, next question.
Okay. So the next question is, which among these layers is responsible for storing and accessing persistent data? So again, you all can answer in the text box. We'll wait for some time. This question has already been somewhat answered by Mr. Ashin. So I guess all of you will be able to answer this particular question. Okay, only 16 responses. Okay, so let's see. Data access layer. Yeah, so all of you are correct. So would anybody like to, does anybody have any question or any clarification or anything regarding this particular question? Anyone? Okay, so we can move to the next question. So, which among these is a small piece of text containing identifying information? So again, you'll have to write down the answer from among these options. So we'll wait for some time. Okay. So only 12 responses out of 24. So let's see. Cookie. Okay, why A? Can you unmute yourself and tell why A? Anyone?
No, HTTP is a protocol. So
Yes,
whatever the question
exactly.
is.
Okay, so can anyone tell what basically a cookie is? Like, not from this particular definition, what it exactly is? Or can anybody like explain what cookie is?
When we are using the web browser, that time some cookies is coming, taking from the server and storing the local space. So whenever I will open the same website,
Yeah.
it will use this cookie for the future use or I mean current use.
Okay.
The cookie is
So,
data.
can you tell what happens if we do not use a cookie? Like an example, if you can give.
It's a kind of a authentication token. So if we do not use it, then every time we want to access the server, we have to log in.
Yes,
Otherwise,
that's correct. Yeah, that's
It
correct.
will ask for the same data.
Yes, that's correct.
It's not a login, any data, any kind.
Yeah, any kind. Login is an example.
Yeah.
Okay, then. So we'll move to the next question.
Ma'am, the question it is showing is different in peer deck.
Sorry?
Yes,
In peer
ma'am. Actually,
deck,
peer
it's a
deck, the
different.
question is different. Different question is being shown.
Okay, just a second.
Sanjay, the question was which layer of application deals with browsers like Google Chrome and Safari? That was the fourth question. Yeah.
Yes, sir. But somewhat it is showing something else. Okay, so can you all answer?
Is that the application layer, right?
Many have said it is a mix of presentation layer, C, B, D. Okay, so can anybody explain? Like why it is a C or B or D? Anyone?
Yeah, actually, which layer of the application deals with the browser like Google Chrome and Safari, right?
Yes.
We are mentioning the application to
Yes.
work. So it will be the application layer, I think. I mean, if I'm not wrong. So that's why
I think combination of logical layer and presentation layer, because presentation layer is also used to present data.
Yeah, but we don't have no presentation layer will be happen. I mean, it is showing the data, but application started, but it does not show the data. I mean, it may be hanged or anything, but application is, or I mean, the OS is already allocated the memory. So that time it is only application. I'm not able to see. Sometimes we experienced like that, right?
Actually, it's a user interface.
That's why I am
so
saying
it has to be presentation layer.
layer.
It is a user interface.
Sure be.
Yeah, so that was the last question, Anjana, right?
Yes, sir. Yes.
Okay. Okay, so please watch week 7 videos, okay? But yeah, lecture 7.4, please watch before coming to the next live session, okay? We will be discussing that particular database to Python database connectivity part. Yeah.
Sir, hope everyone have installed that Python library.
Editor.
Python.
Yes, everyone has
Python.
done the Python course, yeah, so they must install it. Yeah. Any editor, right? Jupyter or Spider, anything. Okay, so is there any question? Otherwise, we can end this session. Yeah.
Actually, I have a Visual Studio, so that I can use, right, for the
Yes, sir.
Python.
Yeah,
That
yeah.
you can use, yeah, no issue.
Yeah, 3.9 version.
Yes, yes.
So what I have asked, am I correct?
Yes, Prashant. See, if we are changing the queue, so somewhere that has been in Mumbai but can't get there due to error in transaction time, then we can say that because then that update will load back.
Excuse me, sir.
Hello, yes.
So in the last question, if we have to choose between presentation layer and application layer, so which would be the correct one?
Presentation layer and application layer. If there is application layer in the option, right?
Yes, sir.
See, basically when you open the any browser, so it will give us the QA, right? So it's presentation layer. But when you try to access some information, then it will be application layer. Right, Ashim?
Yeah.
In both A and B, presentation and application layer combination.
Yes, we can say that, yeah.
Yeah, that is true. But for this particular questions, which option is more appropriate?
For this B option, right? Presentation layer only.
One option correct, then absolutely B. If multiple, then we can go with A and B.
A
No,
and B,
no.
A is application layer, right? Not logic layer.
Oh.
You don't have to choose. I mean, you don't have the option to choose more than one over here. So then most appropriate answer need to be checked. Got my point?
Yeah.
Yeah.
So yes, Prashant. So yeah, if it is an immediate database modification scheme, then we can say that it is
like that. His office has updated that he got transferred from Chennai to Mumbai, but due to technical issue, they need again him on Chennai. Then his transfer got cancelled. So then here transaction time has been used as rollback information.
yes, we can say that. But see, transaction like depends on the which modified schema you are using. If you are using default database modified schema, then it is all the transaction log is present in the buffer storage only. It is not executed in our original memory, right?
Yes,
yeah.
Sir. Okay.
So here in this cases, we can say that it is a transaction time. But still, I will copy that question and I will check that question again. Okay.
Okay, sir.
Yeah. Sorry.
So thank you, sir.
Yes, anyone? Yeah. Okay. Thank you then. Yeah.
Thank you. Thank you, everyone.
Thank you, sir.
Thank you and have a nice day.
Thank you.
Thank you. Have a nice day.
Thank you, everyone.
Thank you. And have a nice day. Love you.